Okay, let's graph a few things. For number 16, I am graphing in standard form. I know it is standard form because the x is squared. I can label my A, my B, and my C if you'd like to. You don't have to. The first thing I'm going to do is calculate my axis of symmetry. That is done by using negative b over 2a. When I plug in, I write down my negative. In parentheses, I'm putting what my b is, which is negative 4. Then I have 2 times my a, which is 2. Negative 4 is positive 4. 2 times 2 is 4. 4 divided by 4 is going to be 1. This is my axis of symmetry. This is an equation, so I'm going to write x is equal to 1. This is also the x coordinate of my vertex, so I can put a 1 as the x coordinate. To figure out what my y coordinate is, I'm going to take this 1 and I'm going to plug it in for each of the x's in my equation. So I'm going to have 2 times 1 squared minus 4 times 1 minus 3. I need to follow my order of operations. 1 squared is 1. Everything else stays the same. Next, I'm doing my multiplication. 2 times 1 is 2. 4 times 1 is 4, minus 3. 2 minus 4 is negative 2. Minus 3 is negative 5. So that ends up being the y-coordinate of my vertex, negative 5. And I can plot that right away. 1, negative 5. Now I need 4 other points for a total of 5 points. I can see in my equation right here, this is where my function crosses the y-axis. It's the y-intercept. So right away, I can plot 0, negative 3. This is not always possible, but in this case it is, and I want to take the easy route, so that's what we're going to do. Where I plotted my vertex is where the axis of symmetry is. It cuts my parabola in half. Each point on either side has a mirror point. So this point is 1 unit away from the axis of symmetry. So if I go 1 unit this way, I will also have another point. That point is at 2, negative 3. I still need to graph another point. Well, I need to graph another 2 points, but I need to figure out another 1 so that I can get the mirror point. My options are to plug in, try to find another color here. To plug in a negative 1, because I already know what 0 is, I already know what 1 is, I already know what 2 is, so I could plug in negative 1, or I could plug in 3. Both of those should give me the same answer because they are mirror points. So let's try to do negative 1. Same idea, 2 times negative 1 squared minus 4 times negative 1 minus 3. Do your exponents first. I don't know why I put a parentheses there. Negative 1 squared is going to be 1. Everything else stays the same. 2 times 1 is 2. Negative 4 times negative 1 is positive 4. And then I have a minus 3 at the end. 2 plus 4 is 6. 6 minus 3 is 3. So when I put in a negative 1 into my equation, my y equals 3. So negative 1, positive 3. Whoops, that's a 2. Up here, 3. I went 1, 2 units away from the axis of symmetry to plot that point. So I'm going 1, 2 units this way to plot another point, which means 2 of my other points are negative 1, positive 3, and positive 3, positive 3. That is standard form.